Hello and welcome to another one of Dee's ADD videos. Today we're going to be talking about related rates. We're going to look at a specific example. Just recapping the rule or the steps real quick. First thing is to set up the equation with everything that you have and everything that you want in it. Then after that, derive implicitly with respect to time. What does that mean? That means derive normally, and any variable you derive, you're going to have to add a d something dt depending on what the variable is. Then plug in your known values and then solve for the unknown missing piece of the puzzle. Alright, let's look at the first example. Let's say that we are inflating a balloon, and the balloon is roughly spherical in shape. Pretend that that's a sphere. And let's say that the radius is changing at a rate of 1 inch per minute. And I want to know what is the rate of change of the volume and the surface area. Alright, well, this was nice because it gave you the actual equation that you needed. So the area, actually let's do the volume one first. So the volume of a sphere is volume equals 4/3 pi r cubed. Then after we've got the equation, this was step 1, the equation. Now step 2 is to derive with respect to time, d whatever dt. So the derivative of v is 1. With respect to time though, we have to multiply by dv dt. Derivative of that is 4 pi r squared, because the 3's cancel, and then you multiply by dr dt. And if you've done everything correctly, you should have everything in your problem, except for the person who made up the problem forgot to give you a radius at which to check it. Let's look at when the radius is 10 inches. So this would be the general relationship between the rate of change of volume and the rate of change in the radius. So in this case, if I gave you a specific radius of 10 inches, you would plug in 10 inches right there, squared, and then the rate of change was 1 inch per minute. Now, the clue that this is your dr dt is that per minute. Anytime you see per minute, that's your d whatever dt. In this case, we're talking about the radius, so it's dr dt. And it's going to be 1 inch, let me go back to red, sorry, per minute. And then when you plug in, your unit should be in inches cubed per minute, so it would be 400, 10 squared is 100 times 4, by, and inches squared times inches is inches cubed per minute, like we expected. Alright, so that's a basic example. Let's look at something else. Let's look at a slightly more complex example. Let's say that I'm on the side of my house painting the side of my house when this ladder that I'm on slips and all of a sudden starts falling down at a rate of 2 feet per second, and the ladder is 25 feet long. And let's say in order to not think about the pain that's about to envelop my body, I decide to calculate the rate at which the ladder is moving away from the base of the building. Alright, and I do this when I'm roughly 10 feet off the ground. Well, the first step is to come up with the equation. What's the equation that relates the legs of a right triangle, right? Because there's no angle information given here. Well, that would be the Pythagorean theorem. And once you get your Pythagorean theorem, the first step is to plug in anything that might remain constant. So in this case, the only thing that remains constant is the ladder. Everything else is changing. Hopefully the ladder is not getting shorter and getting bigger and knocking me into the wall as I'm falling down the wall. And then step 2 is to derive with respect to time, so that would be 2a dA dt plus 2b dB dt. Oops. And the derivative of that is 0. So what do we know? We know that if we call this side up here A and this B, we're looking for dB dt. We know A and dA dt. We don't know B, but we can use the Pythagorean theorem, right? Don't forget your skills that you knew before. We're going to have A squared, which is 10 squared, plus B squared equals 25 squared. So B squared equals root 525. And you plug that in, and then along with the A, which was 10, and the dA/dt was 2 feet per second. But why am I putting this here? Why is that negative? Well, because we're going down, and that's negative direction. Alright, otherwise this dB dt will be the opposite sign than it needs to be. So then plus 2 root 525 times dB dt. Add that over, and we get a 20 times 2 is 40. This is feet over here, I forgot the units. Divide both sides and dB dt is going to give me 20 over 525, whatever that numerical value is. Let's see, let's use calculator. I got 20 divided by parentheses 525 square root plus parentheses enter gives you 0.873 feet per second. Alright? Okay, that's that. So, let's look at another example, final example. Let's try to get some more space by zooming in. So here, if I have, let's see, there's, let's say, a boy is sitting in the bushes with a gun, BB gun, and his little sister just lost her balloon. Sister, let's see if we can draw a little sister with a skirt. And the balloon is going up. Let's say it's going up in purely vertical motion at a rate of, I think I zoomed in too much. Let's go at a rate of 5 feet per second. I still zoomed in too much apparently. So the little brother wants to figure out at what rate the angle is changing so that he can shoot this balloon properly. So, hey! Thank you. Sorry about that. Students getting a little too loud out there. So at this point, what information relates? Let's say that he wants to hit it when it's 10 feet off the ground, and she is approximately 10 feet away from him. Well, we have information about an angle that we want, and we know 2 legs of a right triangle, so that's going to be the trigonometric function tangent. And we know that the x value doesn't change because it's purely in the vertical motion, this balloon, so I can plug in the 10. And then you multiply both sides by the 10. Now you're ready to derive. So that would be 10 secant squared theta d theta dt is what we're looking for. Dy dt we know. So that's 5 feet per second. Running out of space. Let's get some more space here. And then what angle has 2 sides being the same, 10 and 10? That would be pi over 4 or 45 degrees. And the secant of that is going to be root 2, 1 over root 2 flipped is root 2 squared becomes 10 times 2, which is 20 d theta dt equals 5 feet per second. What are the units on the side? Let's see. The 10 is in feet. Okay, so bring that over there, and you're going to do theta dt is 1 over 4. Alright, so it all depends, you know, that what is your information that you're given and what do you want. That's how we actually, this is degrees, right? Or radians, actually. Alright, so pick the right equation, plug in your constants, drive implicitly with respect to time, and plug in your values and solve. I hope this has clarified any doubts that you might have. Please make sure you practice these. This is a source of problems for a lot of people, and the only way to really overcome your fear is to just do a bunch of these, okay? Practice, practice, practice. Thank you and have a nice day.